wavelengths in reflections of cosines and sines. At the beginning of this, I put some notes here. I thought this would be helpful. Whenever we talk about some function, right? So we're going to call it y is equal to cosine of x. That is our original, just plain and simple. Whenever I am looking at y equals cosine of x, I automatically know that when I go start my cycle, since there's nothing else involved, it's going to start at 0, 1. So my cycle is going to start there. Where does it end at? One complete cycle is going to end at an interval of 0 to the period. In this case here, the period is 2 pi. So it's going to end, it's going to go, it's going to do its complete circle, it's going to do, and that's terrible drawing, so my apologies. But anyways, it's going to do a complete cycle. And then it's going to start a new cycle, and it's going to continuously go on, and it'll go on. And how do I know it's 2 pi? Because the period formula is 2 pi over b. Well, where did I get b? Well, I know that this is my original formula, and each part represents something. All right, so here's my b. And we plug it in here, then we got our period. If your A here, which is my amplitude, is 1, then there is no stretching and no shrinking going on. The amplitude tells me that this wavelength is going to hit here, and it's going to bottom here. And whenever we solve for it, we solve for the absolute value of it. However, and I'm going to go over that here in detail in just a little bit. However, in this case here, since you don't see a number here or anything, we know our amplitude is 1. So we got +1 to -1. Oh, what is that? That's going to give me my range. My amplitude in this case here is just 1. And since the amplitude here, in this one here, you notice is positive, our original is positive, then there is no reflection about the x-axis. Now let's talk about sine. Well, whenever I talk about the sine of x and we go plot it, it actually starts the beginning of the cycle at the order pair 0, 0. So there is a difference of where they actually start their cycle, but everything else is going to affect the same way. Okay, so let's talk about C. C is going to tell me my phase shift. And what does that mean? It means that we're going to take whatever is going on, right? And we're going to shift it to the right or to the left. Okay. D tells me the vertical shift. That tells me if we're going to take that wavelength and move it up or move it down. So let's apply what we're learning here on example 1. Example 1 says find the amplitude, the phase shift, the range, and for this function here. So let me highlight it just right quick so you can see it real good. It didn't say nothing about the period, but we really do need to know what the period is, okay? Because it affects this too. So the amplitude, you take the absolute value of it, and if you'll notice here, the amplitude is 1. It's a +1, so it's still going to be positive. Now period is going to be 2 pi over b. And what is b here? B is 1. So it's just 2 pi. So this tells me that my shift, my actual cycle is going to go, going to move every 2 pi. It's going to start over every 2 pi. My phase shift in this case here, if you'll notice, the formula said x minus c, and if you'll look, there's the negative sign. So I know my phase shift is just a +6. If this would have been x plus that pi6, then we would have to factor out the fact that it should have been minus, then that means the phase shift would have been a negative value, okay? In this case here, it worked out nice and pretty. Now, what is my range? Well, we can actually do a mathematical way of figuring out the amplitude. We're going to take half, right, above the x-axis and the y. We're going to take this formula, take half, and we said the amplitude is 1. We're going to minus it by its negative value. And that gives me half times 2, which gives me 1. Boom. What is my range? My range is going to be the this amplitude, right? It's going up to +1, and then it's going to go down to -1. So it's -1 to 1. Now let's find our 5 points. Okay, so this is where the period is important. So whenever I go to find the 5 points, we know that the cosine started at 0, 1, correct? However, we have all this other stuff going on, so this is going to change how we determine. It's going to change actually where everything sets out on the graph. Does that make sense? So let's do this. So in the particular assignment, it may say at the specific point, and it's going to give you a set point, and it's a pi6, 1. It wants to know when, what would be the next interval? Where would it happen at? Well, let's calculate that. So what we're going to do is we're going to see that the interval actually applies at my phase shift. And then for this next point, I'm going to take my phase shift and add on my period. So my phase shift here, plus the period. And I'm just going to rewrite it here, which gives me what? Pi6, 13 pi 6. Okay, so now I got my first point. Let's move on. Let's find our next one. So it says, okay, the next point is going to start at pi halves, 0. So what's going to happen? Well, to find our next point, we're going to take that pi halves that they said, and we're going to add on the phase shift, which in this case is pi6. And when I add that on, I get 2 pi thirds, 0. We're not changing the y value because why? There is no plus or minus d value here. So we're not moving about the the y value. We're not making no changes there. We are, that we still have a consistency of moving around, but we're not making changes there. All right, so let's find our next point. It said the point at pi -1. Okay, let's find that. So I got pi, and I'm going to add on the phase shift. What does that give me? 7 pi 6, and I'm going to leave my y value alone. So I got 7 pi 6, -1. Again, leaving the y value alone just because we don't have a plus or minus d value. Let's find another point. So they said, okay, well, what if it was 3 pi halves, 0? Let's find it. I'm going to take that 3 pi halves, add on the phase shift. And it gives me 5 pi thirds, 0. Now, our last one. It's the one that ends the cycle. So remember, we have a cycle that goes from one point to the next and then starts over and over and over. Well, it says 2 pi 1. So let's calculate it. I got 2 pi. Remember, 2 pi, where did it come from? It was the period. That's where we knew it ended. I'm going to add on the phase shift. Oops, equal sign. Gives me 13 pi 6. And I'm going to leave the y value alone. So now I got 13 pi 6, 1. So this one here was just solving the cosine wavelength.